Today, it's all about the bones of your home as we take a look at all kinds of framing, from studs to boards to foam.
The specific foam that we're using here has a 1 pound density to it.
What exactly are SIPs, and why are they becoming such a popular way to build?
3, 2, 1.
We're firing beams into walls to see which kind holds up best. Plus, man-made I-joists versus good old-fashioned dimensional lumber. One is definitely cheaper and lighter, but wait till you see them burn.
Okay, so right now I'm looking at the wood bowing pretty good right here.
Oh, it's totally giving way.
And seismic simulation. How much does it take to knock down walls? Walls, framing, and joists deconstructed. The mission? To explore the science of home improvement.
Because to understand what you're building, sometimes you just got to take it apart. Hey, I'm Matt Blashaw. Today we are talking structures. From how your home is built to the materials that keep them together.
Most homes are still framed with sticks, 2x4s or 2x6s. It's a tried and true method.
But that is starting to change.
How often have you seen a house framed like this? Full walls, the sheathing, the insulation, all pieced together at once. At Premier Building Systems in Seattle, Washington, they custom make these prefab panels. They're called SIPs.
What is a SIP?
SIP stands for Structural Insulated Panel.
Okay.
A SIP is an alternate to traditional conventional framing.
And since these panels are basically wall sections, building a structure with them is a snap.
So literally, a couple guys like us can build an entire house.
You bet.
I mean, we put this together in a matter of minutes. It saves on time, saves on energy. I mean, it's green.
It's definitely the next step from conventional framing.
And while SIPs framing will cost you a little bit more up front, you can expect to see a return on your energy bill.
From an energy efficiency standpoint, it's exceptional. And generally speaking, we find 50 to 60% savings on energy costs.
Over the lifetime of your home, I mean, that's
Payback is tremendous.
Huge. All right, so show me how this stuff is made.
Let's go show you the process.
All right. This is the meat of the sandwich.
This is expanded polystyrene, EPS.
EPS?
The specific foam that we're using here has a 1 pound density to it.
This stuff is lightweight, strong, and efficient.
If you look at traditional fiberglass batting that gets applied inside a wall, there's a lot of air. We eliminate all the air in the wall.
No air whatsoever.
And here's another advantage over traditional building methods. With SIPs, all the openings for wiring and electrical outlets are made at the factory. A hot wire makes precise cuts in the foam. It works kind of like a giant cheese wire.
This gets hot.
Okay.
What we're going to do is we're going to run it through.
Here we go. Down. Okay. Oh!
If that performed correctly, we should be able to push that right out. Can you pull that, Matt?
Great success.
With the foam cut to specifications, it's time to cover it with OSB.
Now at your local hardware store, you're going to find small pieces of OSB just like this. But here, they use enormous custom cut pieces just like this because from top to bottom, the piece has to be continuous in order to give that home strength. All right, so this is where the meat and the bread become the sandwich.
Our next step is the actual marrying of the 3 critical components to a SIP. That's the OSB, the EPS, and the structural laminate.
They use a strong adhesive to attach the OSB to the foam. Then it all goes into the press for curing. Once the panel is complete, it's marked according to the architectural plan and cut to a custom size.
You have all this high-tech equipment and you're using a chainsaw.
Still the best methodology for these types of personalized cuts, if you will, yes.
And you just look cool doing it.
And we look really cool doing it.
The chainsaw is used for custom pieces, but for the prefab stock panels, they use an automated CNC router.
Why are we behind such thick glass here?
The pieces are spinning at a high revolution out there, and we have had a very rare occasion when the actual router bit has hit something and it's exploded.
Even if the router bits don't go flying, the foam bits certainly do. While the panels are lightweight, they're 40% stronger than conventional lumber. And to make sure of that, they put them to the test. First, they test the adhesive that binds the foam to the OSB.
Ow! All right, so that busted right out from the foam.
We know the glue worked, and that's what we want to see.
Then they test the actual foam for strength.
We're pulling it apart?
That's what we're doing. We're
All right.
pulling it apart. And
Bam.
Our sample broke at 93 pounds.
Past 65 that's passing. That's like a D.
68 is good, yeah.
It's like a D. And we're pulling an A.
Right.
A minus.
While SIP structures have been around for decades, they are just starting to gain momentum in the building industry. The number of homes constructed with SIP panels has doubled since the late 90s. And if the folks at Premier Building Systems have their way, that trend will continue. Still ahead, we're going to put some SIP panels to extreme tests. How will they stand up to a hurricane force? And how do they compare to traditional stick-built walls?
Coming up next, it's missile time.
Plus, man-made I-joists have structural benefits, but there is a drawback that firefighters say you should know about. We're learning firsthand next. We've seen how SIPs are made, but now let's destroy a few to see how strong they are. And for that, we're going to the NTA testing facility in Indiana. So how do you know your house will stay standing when Mother Nature gets violent? At NTA Labs in Napanee, Indiana, they pull out all the stops to see just how much your building materials can take.
All right. So what is NTA? What do you guys do here?
Anything related to building products within our product scope of certification we can test.
Along with traditional building materials, these days they're also testing a lot of prefabricated products.
This is a SIP panel, so this has actually the foam in it.
Yes.
It's got two pieces of OSB.
Yes.
One on one side, one on the other. And that's, you don't usually see pieces of OSB that big.
This is made out of a jumbo panel. This is an 8-foot wide, 12-foot tall assembly.
You might find this type of assembly used as a wall or a roof, so we want to know just how much weight it can take.
This is the axial load test. And what happens is that this giant device puts thousands of pounds of pressure on top of the SIP panel to test its compressive strength.
They've got 90,000 pounds bearing down. That's like 20 mid-sized trucks sitting on the wall. And they keep upping the pressure.
Every minute we're going to put an additional 10,000. 100,000.
Good God.
That's it.
How high did you get?
I think it just broke over 100,000.
Just over 100,000
It's
pounds.
over 100,000? Over 100,000 pounds it took to do that.
It's damaged, but still standing.
So snow load, water beds, you're going to have a whole party up there on your house, on your roof, and I think you're going to be just fine.
I think you'll be fine.
Now that's what happened when we pressed on top of the panel. In the next test, we're going to lay it flat and apply a different kind of pressure.
So you call this the suck test, all right?
It's a transverse wind load test.
Transverse wind load test.
We have vacuum motors on the bottom of this table, and we're going to suck the air out of this wooden box that we've built.
All right, well, let's get sucking.
In this test, they're applying uniform pressure over the panel. Again, simulating wind or even snow load. They get up to 8,000 pounds of pressure, and then...
That was violent.
Yeah. You could have put over 8,000 pounds of snow on this panel at the point where it failed.
Now we have even bigger things in mind. This panel measures 20 feet long.
Bigger panel, bigger vacuum. Let's see what happens. Action. Oh!
The longer panel went a little earlier at 5,600 pounds, but it still held up pretty well.
It looks like it didn't actually break.
Yeah, it bends before it breaks, and that'll give you an indication if the wall is overstressed.
2 tests down, 1 to go. The next one simulates hurricane force winds.
All right, well, let's see the missile. Oh, yeah. This thing's going to fly on how many miles an hour?
34 miles an hour.
Yes.
We got a SIP and 2x6 construction with drywall and OSB. We'll compare how they do.
Let's fire some missiles.
First, we'll take aim at the drywall and OSB.
3, 2, 1. Oh, jeez.
So this would clearly be a failure.
Whoa, clearly.
Without any insulation to slow it down, the missile went clean through.
That wind will enter the house or the building. You'll create a positive pressure on the inside of the house, and that's where you see the windows exploding out of the homes walls blowing out.
Absolutely, the whole Wizard of Oz.
Right.
Pop the roof off.
Now we'll shoot at the SIP wall with a foam core. And this time, I'm doing the honors.
Boink! Right back at us. Look at this. That was the same speed, right?
Right, 34 miles an hour.
34 miles an hour.
It ripped the front, but
Around the backside, clean.
Yep.
Nothing. That's impressive.
so even though the OSB was cracked, the foam was strong enough to stop our missile. Good to know if you live in storm-prone areas. NTA is all about testing building materials, so our homes can withstand the worst conditions. How can you tell which walls in your home are load-bearing and should not be messed with? Any outside wall should always be considered load-bearing. But remember, a remodel can turn an exterior wall into an interior one. A look at the foundation will help determine if that's the case. Another trick? Check the joists in the attic. If a wall runs perpendicular, it's likely to be load-bearing. When in doubt, get an engineer's opinion before you go knocking walls down. Up next, meet engineer Deanne Bell, who helps us compare dimensional lumber and engineered I-beams.
Here we go.
Deflecting.
46. Oh, that's some good deflection. That's the mouse. Nice.
We're putting these joists to the ultimate strength test, and then we'll see how they burn.
The thicker wood is really kind of keeping it contained.
Which type of wall systems are strongest? We're gonna rack them all till they fall, so stick around.
More and more these days, people are using this stuff to build their house.
It's an I-joist made of engineered wood. Essentially wood particles and veneer strips held together with strong adhesives.
It's lighter, cheaper, and they say stronger. But is it stronger than dimensional lumber? Well, I brought an engineering expert, Deanne Bell, to help us out. How's it going?
How are you?
Good. Now, have you ever worked with this stuff before?
A little bit.
All right. So what makes it so strong?
Well, it's all about this crossing. It's all about that shape. As this sags, everything on the bottom is stretching, everything on the top is compressing. What's great is right in the middle, there's no stress at all. So we remove all that material and you get similar structural integrity, less material.
Less material.
And because the wood is engineered, the beams can be made much longer than dimensional beams. So how do they compare in terms of strength?
What are we going to be doing?
Breaking beams
Love it.
with an excavator.
Ah, love it. All right, cool. So we're going to be actually putting pressure down on these things to see when they'll crack.
Exactly.
And to measure the force from the excavator, we're using this, a load cell. It will tell us exactly how much weight we're applying to our joists. First up, our dimensional lumber joists.
Let's see what this sucker can do. Here we go. 600s, 800, up to 1,000 already. 14, 15, 16, 17, 2,000.
Come on.
Here we go.
It's deflecting.
46. Oh, that's some good deflection. 48, we're up to 5,000. 5,000. Nice. Well done.
Right there, that knot. Look at that.
All right, so that broke at 5,100 pounds.
So how will our engineered joist fare?
500, 600, 700,
Okay.
800, 900, 1,000, 12, 13, 14, 15, 16, 20,
Let's see a little
3,000,
deflection.
32, 34, 36, 38, 37.
Deflecting this. There we go.
The composite I-joist snapped at about 4,800 pounds.
So they're actually pretty close.
They're pretty comparable.
Yeah.
You think about how much lighter this is, how much cheaper it is. You're basically using scraps to make this.
Recycled material. I mean, there's a lot of advantages. So dimensional lumber and engineered wood, structurally speaking, are pretty comparable in terms of strength. But how do they hold up to fire? Let's cook some floors.
We made two 4x8 floor systems, one with dimensional joists and the other with composite I-joists. Then we put 200 pounds of concrete blocks on top of each and plenty of fuel for our fire underneath.
All right, you ready for this?
I'm ready. Let's let the battle of the burn begin.
Battle of the burn. All right, ready?
On your mark.
Aim, fire.
At just 2 minutes, it was clear our engineered floor joist system was burning faster and hotter than the dimensional wood.
Look at that curl. Look at that curl right there.
Just looking at it from now, the difference between this flame and that flame
It's night and day.
is night and day. Doesn't look like that's catching fire as fast. That is a serious barbecue over there.
Yeah, right here we're still contained in the middle.
Yeah.
And it seems like the thicker wood is really kind of keeping it contained.
It's holding
Weird.
it.
Look at that. It's just totally belling out the sides.
It usually takes the fire department about 12 to 20 minutes to respond, but at just 6 minutes into our test,
Okay, so right now I'm looking at the wood bowing pretty good right here.
Oh, it's totally giving way. It's totally giving way right now.
Here we go. I think we're going to have a
There's
collapse.
There's a hole on the left. It's bending.
Look at
It's
that.
bending. Oh, wow. Look inside there.
Here we go.
The OSB
Any
in the middle
second
is
now.
totally giving way.
And looking it over to the other fire with the dimensional lumber, it's holding up pretty good. I mean, there's nothing. There we go.
as for our dimensional joists, it took almost 3 times longer for failure. While no one is suggesting that engineered I-beams shouldn't be used, firefighters do say your escape time during a fire may be less than with dimensional joists.
There are fire precautions that you could take with the engineered lumber that could help, but in its raw scenario, there are definitely some weaknesses.
Well, all in all, when it comes to fire, dimensional lumber, clear victory.
Clear victor.
Coming up, earthquake simulation. How will 3 basic wall structures hold up to seismic stress?
Your way. Heave.
We're gonna get racking next. Walls are designed mainly to support weight from above, but sometimes Mother Nature stresses walls from the side.
One of the pressures that can be put on a wall from either seismic activity or even wind is called racking. It's horizontal pressure that can tilt a wall or even cause it to fail if it's not supported correctly.
Wall strength is determined by the combination of framing and sheathing. We're going to try to demonstrate that with a racking test. The National Association of Home Builders uses a racking test uniform wall strength. Our test is a little more informal. First up, a basic stud frame.
Very simple, no supports, bolted to the ground. Let's see how easy it is to push over. So, as you can see, with no support, it's pretty easy to push over.
I'm bringing in Justin for the next wall to help me install a cross brace. Cross braces, or let-in braces, are usually notched into the studs, but fastening it on top should give us pretty much the same effect.
So the cross bracing is really used to stop the racking itself. So this is, we're going to have quite a time with
I think
this.
so. Oh, I can already feel it just carrying it.
Already solid. My way first, ready?
It's not going anywhere.
A little geometry goes a long way. Looks like we need a little more leverage.
Rope! Tug of war time. Try it now. All right, so we're going to pull your way first.
That sounds good.
So your heave, I'm hoe.
Okay. I like that.
Okay. Your way. Heave. Hoe. Heave. Hoe.
Looks like manpower isn't enough for the cross brace.
Hoe.
Time to get creative.
All right, bumper.
All right, light it up, buddy.
Don't fail me now. All right, man, here goes.
Is the bumper going to stay on?
Roll versus truck. Here goes.
It's not even budget. Oh, there it goes. Nice.
Yeah. Boy, it's amazing, man. A little piece of, that's 1x2 we put in, but a little cross bracing makes all the difference in the world.
Now we're adding an OSB sheet to our final wall. Sheathing is often used under siding, but not always. Whether panels are nailed to the whole wall or just corners, they add a lot of strength.
This is code, man. This is
legit.
We know we can't pull this one down on our own, or even with a truck. So we're going for something a bit bigger. Hopefully your house will never have to withstand an assault like this.
That's good. Perfect. I think you've got enough power.
I think I got enough power, man. You ready? Just guide me in.
Let's do it, man. Knock it down, kid. Oh, get it! Get it, man!
Utter complete destruction.
Chewed it up completely out.
But interesting, man. It ripped right down the middle of that OSB. It's code for a reason.
It is
at
code
this
for
point. Let's take this thing on the road.
Yeah, let's take it downtown.
Yeah, why not?
You might be surprised to learn that in an earthquake, wood-sheathed homes fare better than masonry and steel because they have a little more give. For more deconstruction,